Hi, my name is Eric Yu, and today I'll be talking about invasive species, namely zebra mussels. Zebra mussels are an invasive species first discovered in North America in 1986, around Lake Erie, part of the Great Lakes. They are originally from Eurasia, and were likely ejected from the ballasts of large ships coming in from Europe. Their ability to attach to any solid objects in the water and their microscopic planktonic larval stage allowed them to spread rapidly through the interconnected commercial waterways of the Great Lakes. They often clog pipes and water supplies, including those of nuclear reactors, which often cause massive problems for those industries. Zebra mussels are also harmful to local wildlife, reducing phytoplankton biomass, increasing the water clarity, and the increased fecal and pseudofecal matter produced by the mussels increased plant growth, which benefited many types of snails and toxic algae. The density of these mussels also negatively affected fish populations and drove native mussels to extinction. Because of this, scientists wanted to implement different ways to measure and control the mussel populations. The main question that I wanted to answer today is the increase in the population of zebra mussels recorded in Lake Mille Lacs, the lake where they originated, linear? And if not, what was it? First, we'll begin with the sampling method that the scientists used, and the data that I used. They first put 20 monitoring stations around the lake in different places, less in the north because more of the mussels originated in the south. They distributed the stations around a variety of hard substrates like cobble, bedrock, and even some gravels. In 2009, the number was forced to be reduced to 15 because the stations were starting to affect the local habitats. Various ways were used to measure the density of the number of mussels in the certain area. Initially, 2 divers would dive down and follow the transect line, counting all the visible mussels, but soon there were too many mussels, so beginning in 2011, divers brought up samples in plastic and mesh bags to be counted. Then they took the mean densities from each transect and put them in the list. Here's the data that they recorded from their dives and their recordings, and on the right I have an average of all of the data that they put. For my calculations today, I will only be using the average total density in mussels per square meter. Simply by plotting these points on a scatter plot, you can tell that it's not going to be a perfectly linear regression model. Still, however, using the linear regression model for the graph of the years from 2005 to 2015 versus the total average density of mussels, we find that t equals 4.1196, the p-value is 0.0026, and the line of best fit would be negative 2068.2692 plus 1381.2863x, where x is the number of years from 2005. While the R value, 0.8084, shows a strong positive linear correlation between the density of mussels and the number of years, the coefficient of determination is only 0.6535, meaning that only 65.35% of the density in the mussels can be approximated with the linear regression model. Since the coefficient of determination is quite small, it would be much better to split the data up into 2 parts, one from 2005 to 2012, and one from 2012 to 2015, to get a more accurate regression model. And so, after working that out, I found that using a quadratic model for the graphs of the years from 2005 to 2012 was the best, and that using a linear model for the graphs of 2012 to 2015 were the best. For the first part, 2005 to 2012, the R-squared coefficient of determination is 0.8949, which is much better than it was before, at 0.6535. The R value, 0.9460, shows a very strong positive correlation between the total average density of mussels and the number of years. Using a linear model for the second part, 2012 to 2015, we find that t is negative 4.3017, and the p-value is 0.1454. We can also find the linear model that best represents this decrease in mussel density, and that would be 23,452.6667 minus 15,015x, where x is the number of years from 2005. And also, we would have a strong negative linear correlation, because the correlation coefficient is negative 0.9740. The coefficient of determination is also quite high, being at 0.9487. And since both coefficients of determination are quite high, We can see that 89.49% and 94.87% of the variation in mussel density can be explained by the approximate quadratic and linear relationships with year, respectively. With these calculations, we can also make predictions over the next 3 years. If the trend stays constant and the number of mussels continues to decrease at this linear rate, we can plug in the next years, 2016, 2017, and 2018, into our formula. To get x, we would only have to subtract those years by 2005, since that was our starting date. And with that, we would get an answer for 2016, 2017, and 2018, being 6,787.6667, 5,272.6667, and 3,757.6667. And that's the density, mussels per meter squared. In conclusion, the model shows that the rate of mussels increased at a quadratic rate, but now it's beginning to decrease linearly. And this is likely due to the efforts made by the U.S. Fish and Wildlife Service to combat this invasive species. They report sightings and instances of these mussels to the Non-Indigenous Aquatic Species Information System, which is a national system that helps combat invasive species such as zebra mussels. Zebra mussels are an invasive species that have spread across the country. There's not one method that kills them off completely, as most of those methods hurt the local wildlife as well. Things such as chlorine and metal-based solutions, filtering systems, hot water. These things work, but not to the extent that is needed. Other invasive species also can be problematic, and having good boating habits are necessary to prevent these from spreading like the zebra mussels do. The best thing people can do to prevent the spread of these non-native species is to just clean the hull of their ships often with soapy water, and keep water from live wells with live bait in them from contaminating other water sources. Having these good habits will prevent the spread of more invasive species, ones that could potentially hurt more than zebra mussels. Thank you for listening to my presentation. Here are my sources.